Hi and welcome. This is your last lecture for the mechanical side of things when it comes to STC 4006. So I really hope you enjoyed the mechanics. This is an introduction to mechanics and hopefully will give you the base understanding leading into your biomechanics module in second year. Please watch this whole lecture before you attempt the online tests. It shouldn't be too hard for you if you can understand the concepts and the calculation examples that we provide here. I will ask if everyone can make sure that they have a Casio type calculator when doing these calculations. The iPhone calculator is not very good for when dealing with trigonometry. It does things slightly differently. It can do it, but you'd be much better off working with some form of actual calculator. Okay, so the best way to discuss the and show torque and how we calculate it is actually by going through example questions. So that's what we're going to do. And I've tried to link each example question here to the elbow and the biceps. Usually the questions that happen on the online test, they're typically either of the elbow or they are of the knee joint. So if you can do really well with the elbow, you'd have no problem with the knee joint because it's pretty much the same. Okay, so let's go through question 1. The athlete is performing a bicep curl. The elbow flexors produce a force of 500 newtons and have a moment arm of 6 centimeters. So they're telling you what the moment arm is in this case. And we've simplified it here so that it's easy to see what the moment arm is. Then you've obviously got another torque being generated. Torque has been generated by the dumbbell as well. The dumbbell is being held in the hand of the athlete. And then where the dumbbell is applying that force is 40 centimeters away from the elbow. So the elbow is acting as the pivot or the fulcrum. And then you've got the two forces acting on the lever system, one from the bicep and one from the dumbbell. Okay. And what the question wants you to do is to understand, if you put all that information into the equation of torque equals force times moment arm, okay, is the bicep working concentrically, isometrically, or eccentrically? Okay, so if we know we've got the equation of torque equals force times moment arm, and we also know that in this situation we've got two torques being generated, one by the elbow flexors and one by the dumbbell itself. So you've got two equations to work out. Now, if the answer to both of those torques, so the flexor torque by the biceps and the dumbbell torque, if the answer is exactly the same, we know that currently it's an isometric situation because one is not greater than the other, so it's in equilibrium. The elbow is just holding it there still. If we change that, if we develop more force from the bicep, which creates a greater torque, and that torque is then greater than the torque developed by the dumbbell, we get a concentric action. We know that the flexor torque is greater, so that means it's closing the angle between the forearm and the upper arm, so you're going to get a concentric action. The bicep itself is going to get shorter. Opposite to that, what happens if the dumbbell torque is greater than the torque being generated by the flexors? That means the muscle itself will be working eccentrically because gravity will be pulling that dumbbell downwards, so therefore the flexors would actually be lengthening. Okay, so actually let's figure this question out, and I've put the information from two slides ago just here in the red box, so we don't have to keep going back and forth on the slides. So the information we got from there was that the flexors were producing a force of 500 newtons. We had a moment arm of the flexors, which was 6 centimeters. Or in this case, because we want everything in meters, it's 0.06 meters. We've got the dumbbell force. Now, the original question actually gave you a mass of the dumbbell, which was 10 kilos, but we know that mass is measured in kilograms, not in newtons. So to turn it into newtons, you need to times it by the gravitational constant of 9.81, and that will give you the force being generated by the dumbbell. And then finally, you've got the dumbbell moment arm, which was 0.4 meters or 40 centimeters. So we have our equation, which we want to find out the answer to for both the flexors and the dumbbell. Okay, so let's do it for the flexors first. Quite nice and simple, 500 times 0.06, which gives us 30 Newton meters. Remember the new units. We'll calculate it for dumbbell, the torque generated by the dumbbell. So we've got the force, which is obviously 10 times 9.81, and then we'll multiply that by the moment arm, which is 0.4, which gives us an answer of 39.2 Newton meters. So here we can clearly see that the dumbbell torque is greater than the flexor torque, and therefore the muscle is working eccentrically. So we're probably at everyone's favourite topic. I'm sure looking at this slide is giving people anxiety from their maths that they learnt in school. But don't worry, you don't need to learn it in a huge amount of detail, but you need to be able to apply it effectively. So let's just go through a reminder of trigonometry, because we all know that quite often, especially you would have known this from the torque lecture, is that as for example, a bicep opens and closes, the moment arm actually changes length. So we need to, and because of that, the bicep actually attaches on the forearm and then at an angle. So if there's an angle, we need to therefore, and the moment arm is always changing, we need to be able to calculate this moment arm. So quite often with a question you'll have to find the moment arm before you actually have to calculate torque. Therefore, we need to know how to use trigonometry. So let me just put your focus on the blue triangle. You see, it's a right angle triangle. Okay, so you can see one of the angles is 90 degrees. And typically what you'll find is with a particular question, it will either give you two values of the lengths of the sides. So you can either use Pythagoras to calculate the length of the third side, or it will give you one length of one side and an angle. And because of that, you have to use trigonometry to find one of the length of another side. So we need to understand what are the three sides called. So that means we can choose the right trigonometric function to do the calculation with. So we always know that the hypotenuse is the longer length, and usually that's the one that's opposite the right angle. We also know that the opposite is the one that is opposite the angle that is given to you in the question. If we've got two names of the lengths of the sides, we know that the adjacent is the third length. And does everyone remember SOHCAHTOA from school? So if, for example, you get a value of one length and you need to find the value of the other length, that gives you two of these sides. So you always identify which sides they are, because that's then going to tell you what trigonometric function that you need. So for example, if you need to use sine, it's usually because you've got the values, or need to find the values of the opposite or the hypotenuse. So if you go to the right hand side of the slide, it's sine OH, so that's where SOH comes from. For cosine, it's adjacent over hypotenuse, so it's CAH, so that's Ka. And then you've got tangent. Tangent is opposite over adjacent, so that's TOA, so that's TOA. So that's where you can see where SOHCAHTOA actually comes from. And it's quite often easy to write this out before doing an exam question, because then you can just see, oh, okay, we've got this information, I need to use that one. Right, let's just go through a really basic GCSE maths example just so we can put that into practice. Okay, here we've got our triangle in red, and we can see typically we've got one length, okay, which is 12, and we've got one angle which is 25 degrees. Okay, So in this case, we want to find the opposite. So first of all, if we need to find the opposite, we need to know which side is which. So we need to label the triangle. We know that the hypotenuse is the long one that's opposite the right angle. We know that the opposite is the one opposite the angle that you're given, and therefore the adjacent is the one that is left. Okay, so in this case, it wants us to find the opposite, so we need the trigonometric function that has O in it, but at the same time, we've been given a value for 12. Okay, cool, that's the adjacent. So we need the trigonometric function which has O and A in it. So what trig function is that? Well, that's tangent. So you've got tangent of the angle equals opposite over adjacent. So if we then put that information from the red triangle into our equation here on the right, we therefore get tan 25 equals opposite over 12. Okay, so when you're using your Casio calculator, it isn't tan times 25. What you'll find is if you click on the button that says tan, it will open up brackets. If you put in your angle, which in this case is 25, and close the brackets and press enter, it will give you the value of tan 25. Okay, but we want to find opposite on its own, don't we? So if it's opposite divided by 12, we know that we have to multiply both sides by 12 to get opposite on its own. So the equation ends up being opposite equals tan of the angle 25 multiplied by 12, which should give us a length of opposite, which in this case is 5.6. Okay, so try and review this slide again, write down these rules, and then once you've got that, utilize those rules for answering questions on the online test. However, we'll go through a particular question which hopefully should help. Okay, here we've got a graphical representation of an elbow. You can clearly see that the black line is the force being produced by the muscle, which is 100 newtons. We've got the two orange lines, which are the bones, and then we've got the fulcrum of the elbow joint itself, which is that blue circle there. We've also got the distance between where the muscle attaches on the forearm on one side in relation to where the center of rotation of the elbow joint is. So that is 3 centimeters. And the question here is, calculate the amount of torque generated at a joint when a muscle attaching to a bone 3 centimeters from the joint center exerts 100 newtons of tension or force at an attachment angle of 60 degrees. So that value for 3 is just the distance between the fulcrum and where the muscle attaches on the bone. It isn't actually the moment arm. So clearly with this example, we need to find the moment arm before we can calculate the torque generated by that muscle, which is the black arrow, creating 100 newtons of force. So we need to find the moment arm. So I've listed that moment arm, that dotted line there, as MA, and we'll refer to it as MA throughout answering this question. Okay. We need to identify what sides of the triangle that we need to use. Okay. So in this case, we want to find MA. So what side of the triangle is that? Well, that is opposite the angle that is given of 60 degrees, so that must be the opposite. And the other value that we're given is 3 centimeters, okay, and that's opposite the right angle, so that's the one we'll use. We need opposite and hypotenuse, okay. We don't want to use the 100 newtons at the moment, even though there's a value there. That value isn't in distance. The moment arm is in distance, and the only other value of distance there is 3 centimeters. So those are the two sides that we want to choose. So we've got our labeled triangle, and we've got a opposite, and we've got the opposite and the hypotenuse. Okay. So which trig function is that? Well, that's SOH, isn't it? SOH. So we want to use the sine function. So let's put that information into our equation. We've got sine 60 equals opposite over hypotenuse, which actually, in our case, we've got MA, because I've called moment arm MA in this case, divided by 0.03, because 3 is in centimeters, we need it in meters. Okay? So, obviously, we want MA on its own. So if it's MA divided by 0.03, we've been through this before, you need to multiply both sides by 0.3. So moment arm ends up being sine of the angle of 60 multiplied by 0.03, and that will equal 0.026. This number, if you actually do it in your Casio, is actually much longer, but I've just rounded it up here to make things a bit more easy and a bit more clear. But typically you'd probably keep that value up on your calculator when doing the next bit, because we've got our moment arm, but we need to find the torque that's being generated. We just had to find the moment arm first. So we know that torque equals force times moment arm, so we end up putting 1000 multiplied by 0.026 equals 25.98 Newton meters. As a little tip, generally the questions end up being quite similar, so you need to use sine as the function. However, I would still go through this strategy of trying to find out the information you need before actually finding the value for torque. I have also put some as a Word document where there's some example questions on there as well, so you may want to do them first before going ahead with the online test. However, good luck, and I'll see you all soon.